Greetings, calculus students. This is Mr. Myring coming to you one more time with an online video. In this particular one, we're going to be looking at taking the limit of the average rate of change to estimate the instantaneous rate of change, something we've been working with a lot, looking at that AROC and how we can find our IROC in multiple ways. So the example that we will use for this is that what we're going to do is find the three average rate of change values to estimate the instantaneous rate of change of the function 0.5x squared plus 3x plus 2 at the x value of 4. Now, this is the formula or equation rather, that we've been using in our previous videos, so it should be familiar. Everything should connect that way. That's done on purpose. And we're going to be finding three different values to estimate this. So this is like an analytic way, looking at the actual formula and looking at the equation. So, the reason we're going to take three of them is because we want to take a look at what these values are approaching. So what are these values approaching? And the reason that's such an important word for us is because this idea of what they're approaching is going to be what is the limit for us. And that was in the title screen, to find the limit. So in order to do that, one of the easiest ways to organize this information is with the table. So I'm going to make a quick table here, and in this table it's going to have three columns. The first column is going to be 4, second column is going to be x, and the third column is going to be the average rate of change on this interval. Right, so this is going to represent for us, here's x equals 4, that's where we want the IROC, so we're going to use 4, and x is going to be the other value. Now, you don't have to use 4. It's a nice way to do it. There are other ways. You might see other examples moving to the left and right of 4, but we're going to use 4 for every single one of these three average rate of change values. Now, by doing this, we have to pick out what the x values are going to be. So we're going to be picking values that are close to 4. If you recall all this information about the limit from previous classes or what we've talked about already, the IROC takes place at the tangent line, right? So we want to be working with a tangent line, but of course the average rate of change is not the tangent line. The average rate of change is the secant line, which is why you need two values, 4 and something else, but we want to get closer to the tangent line, so we pick out values that are getting closer. So let's say 4.5 is pretty close, but we can do a little better, 4.1, and we can do even better than that, 4.01. So now these are the intervals at which we're going to use to find the average rate of change, to look at those values and hopefully see what it's approaching. Now, you can do this in several ways, but we've already looked at a video that talked about the average rate of change expression. So if you need to go back to that video to review how to do that, you may do that. But the general rule for the average rate of change expression is this f of b minus f of a all over b minus a on the interval a to b. Straight up, old school slope. So between 2 points, what is the slope, which of course is the average rate of change? So for our particular example, this is going to be negative 0.5x squared plus 3x plus 2 minus 6, and that's all going to be over x minus 4, because that's on the interval 4 to x. Again, that was in that previous video. This does simplify pretty nicely down to negative 0.5x squared plus 3x minus 4 all over x minus 4, still on the interval 4 to x. So here is your average rate of change expression. That's what we want. Here are the x values that we're going to be plugging in here to figure out what that AROC is. So again, this is our AROC. So lots of ways to do that. One of the easiest ways is to take this formula, this whole thing, put the top in parentheses, put the bottom in parentheses, and plug that into your graphing calculator as y1 or y2, depending on what else you've got in there. And then you can just plug in these values into your table, and it'll just pop out that average rate of change without you having to do any computations or anything. So that's what I've done. And so between 4 and 4.5, you get the value of an average rate of change of negative 1.25. Here you get negative 1.05 between 4 and 4.1. Between 4 and 4.01, if you calculate it and compute it correctly, you should get negative 1.005. Well, there you have it. There are three average rate of change values. we're going to see what they are approaching to take the limit to estimate the instantaneous rate of change. So 4 is used for all of these, which is why these, whatever they're approaching, is going to be that estimate of the instantaneous rate of change. So as these values here are getting closer to x equals 4, that's your limit process. We take a look at what these values are getting close to here. And if you take a look, pretty easy to see that these are getting closer to the value of -1. So that would be my estimate to the instantaneous rate of change. So my AROC at x equals 4 is -1. So that's your instantaneous rate of change. That is the slope of the tangent line, and we're using average rates of change to estimate that. Right? This is still just an estimate, but it's a very good estimate based on what we understand about the limit and our average rates of change. Again, don't forget to include units if you need to. Units attached to the problem. Make sure you have units attached to your answer. I just wanted to make sure I didn't forget to mention that. Thank you.